Okay, one of the homework questions that we had on the last set, dealing with trig functions and transformations, asked you to do some work on a regression. So I just wanted to take a look at an example, and then we can talk about it and kind of work you through so it makes a little bit more sense. So I've got an example problem here that talks about the mean monthly maximum temperature for Cape Town in South Africa. And it shows all that. And we're going to model it in that form where January is first, February is that. So we're going to first draw a scatter diagram. So to do that, I've helped myself out and I've got these values here. You can see this is going to be months here. And this is going to be mean temperature. So we've got the months and the mean temperature on those two axes. So I'm just going to quickly plot these. So if January is 1, then it's got to be at 28. So if I go on 1 up to 28, that puts me there. And February is 27. March 25 and a half, so right about there. 22 for April, 18 and a half for the next one, 16 for the next one, 15 and 16 is going to be there, 15, 16, 18, 21 and a half puts me right about there, 24 for the next one, and 26 for the last one. Did I miss one? January, October, November, December. All right, and then December was what, 26. All right, so looking at this right off the bat, looking at this, I think we can say that that looks fairly sinusoidal, right? So we've got it. We can guess that this is going to be some sort of cosine function, but it asks us to do this as a sine function. But that's the first part there. Now, without using technology, estimate our b value. And remember, that b value, it's going to be dealing with the period, right? So the period is always 2 pi divided by b. Well, if I look at this, it looks to me like this is my maximum. And I don't have another maximum at the other end, but I do have my minimum here, right? And because of symmetry, we can assume that the next max is going to be just double if we go from max to min. So looking at this, if I go 1, 2, 3, 4, 5, 6, 7, so we've got 6 here. So my next max would be after 6 more months, which means my entire period is 12 months. Just thinking about this logically, that makes sense. We're talking about over the course of a year. In the southern hemisphere, January is the warmest month, so it would make sense that we get back to that. So my period is 12 is 2 pi over b. Well then, b equals 2 pi over 12, which I can simplify that to b is pi over 6. So that is my first answer. We've got pi over 6. And that white really shows up well on that. I apologize. Yellow is almost worse. All right, so next we need to figure out the a value. Okay, well, in order to find the a value for any function, a value is always the max minus the min all divided by 2. And that will give you our a value every time. Well, the highest value I can see is January. The lowest value is in July. So to find my A value, it's just 28 minus 15, all divided by 2. 28 minus 15 is 13. 13 halves would be what our answer is, which again, that's what, 6.5. So we've got an A value. So if I was going to start constructing this function as they've had here, where t is equal to, and I'm doing this as a sine function, sorry, oh no, x minus, I've got other stuff going on here that I didn't realize I had, I apologize. So I've got 13 halves for my A value. My B value is pi over 6. All right, my D value, well, to find the D value of a function, oh, my scale is off here. I see what my problem is, but we're fine. We can do it on those units. It's all right. My D value is always going to be max plus min over 2. It's the average. So I'm looking for the value in the middle here. So if I'm just going to do my average. So again, we know that our max was 28. Our min was 15. And I'm going to divide all that by 2. 43 over 2. Okay, which is what, 21 and a half, somewhere in there. Looking at that, does 21 and a half look about right? I can see that as probably about the right value. So I found my D value. I'm just gonna 43 halves. And then the last bit is finding my C value. Now, there's lots of ways of doing it. My personal preference when finding my C value is just to use algebra, because algebra doesn't lie, and I think that that's the best way of doing it. So in order to do that, I'm going to pick a maximum point. So my first maximum point is at 1 and 28. And again, I'm pulling that because January we're calling the first month. 28 was the highest temperature we saw, so that's my maximum point. So I'm going to use this equation, and I'm going to say that it was 28 degrees when this function, 13 halves of the sine of pi over 6 x, sorry, I can put that 1 in there, because that's my x value, minus whatever my c value is, plus 43 halves. Okay. I'm gonna put my C in pink, I guess. All right, so now I just have to solve this. So this would turn into, and I am lazy enough that I'm just gonna pop my calculator out here, and I'm going to do 28 minus 43 halves, and I get 13 halves. So I'd have 13 halves is equal to 13 halves sine of pi over 6, 1 minus c, because I'm just subtracting again from, if we're not following, I subtracted 43 halves minus 43 halves, and that got me to there. Now my next step would be to divide by 13 halves. Notice it's the same number, so I'm going to get 1 is the same as the sine of pi over 6 times 1 minus c, and that's going to be my value. Now, I'm going to do just a little bit of maybe a sneaky trick. If we think about the unit circle, and this is 1, 0, this is 0, 1, and again, unit circle is cosine theta, sine theta. Where is sine going to be equal to 1? Well, hopefully you recognize it's up here, and that corresponds to pi over 2. So the sine of pi over 2, because these two are equivalent statements, right? 1 is the same as the sine of pi over 2. Just, again, if I do the sine of pi over 2, I get the number 1. So I'm just replacing 1. And the reason why I'm doing that is so that I have a sine function here and a sine function on the other side. And by forcing those two to be the same, what that means is all of this that is inside of here has to be the same as what is in there, which gives me my next step, that pi over 2 is equal to pi over 6, 1 minus c. And then my last step, I'm going to just undo this, so I get 1 minus c. I can do it in color because I'm a big boy, is going to be 3, because pi over 2 times 6 over pi. Pi's cancel, 2 cancels, I'm left with 3. So I'd be left with negative c is equal to 2. So therefore c has to be negative 2. Getting that all into my formula here. So my c value is negative 2. So my final answer for this is the temperature is equal to 13 halves of the sine of pi over 6 x. Well, it's minus negative 2, so it's going to be plus 2. And then plus 43 halves. Okay? So that gives me an estimate of this. That gets me to this first thing. We have a value for that. Now, I'm not necessarily happy with that because I think it should be a different value, but we're going to go with that's what it is. That's the general process. That's how we go through it. Now, it asks you to check your answer using technology. We can totally do that. So in order to do that, we are going to take our calculators and we are going to, so I just need to resize a couple little things and this will work a lot better. All right, I'm going to take my calculator and I am going to do Control Page and I'm going to open up a list and spreadsheet. And now I'm just going to filter in, I'm just going to put in that data. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And it's 28, 27, 25.5, 18.5, 16, 15, 16 again, 18. I feel like I missed one there. Is there one missing in the middle there? January, February, March, April, May, June, July, August. Oh, we're good. 19, 18, 21.5, 24, and this last one was 26. 26. All right, so once I have all that data in there, I'm going to go back up to the top. Notice the red shows you what I'm pressing. So I'm pressing up, and I'm going to get it so that I'm hovering over this particular thing, and I'm going to press menu and statistics, and then escape one back. I'm going to go statistics, and then I am going to go down until I see sinusoidal regression. What that does is it forces the calculator to make this regression for us. Okay? So sinusoidal regression, my X list is my month, my Y list is my temperature, and I'm going to have it saved to there. I'm going to press enter. And now this is going to give me the sinusoidal regression. It's really important you see what it says there. It is A sine times B times X plus C plus D. So all of these values, that's the A value, that's the B value, that's the C value, and there's my D value, okay? So I'm going to pull these over, but it is important to note, your calculator, again, gives you this in a slightly different form. So from the calc, it gives you A sine BX plus C plus D. Notice that's different than the way that we normally do it. Normally we do A sine of B times the quantity X minus C plus D. So in order to make this work, we have to do just a little bit of work, but let's write down what we have. So what the calculator is saying, and again, I'm pulling it from right there, you can just barely see it, is the calculator is saying that this should be 6.397 sine of 0.58518 times X plus, I gotta check that was that negative number, 0.9965 plus 0.9965, and then I'm adding plus 21.26. Okay. Now, in order to make it into this form, so I can compare this to that, option one would be I could just distribute this pi over 6, and we would compare the two. Option two is I can just divide all of these things. Like if I divide this by that, I can separate it out. So that's what I'm going to do. So 6.397 sine of 0.58518 times X plus, and then, sorry, this was, I lost my values. 0.9965. 0.9965 divided by 0.58518. Could be 1.023. All right, so we end up with something that looks like that as my regression. Now, I want to compare it to this one here. So just to compare it to this one here, I'm going to do 13 divided by 2. Well, we already know that we already know that that is 6 point, sorry, different color. We can do this. Big boy time. 6.5 sine of, well, we need to know what pi over 6 is. option pi divided by 6 with the decimal, 5.24. And 43 halves, we already said, was 21.5. Now, looking at these two, they are definitely not the exact same. In part, this is because our regression doesn't follow, it's not perfectly sinusoidal. It's close, but it's not perfectly sinusoidal. And we can check that by looking here at this, my regression equation. We can look at the residuals and we can see that it's not an exact fit. So it's not actually perfectly sinusoidal, but we have a solid guess. And again, the question said make an estimate and then use your technology to check. Are we close? Is 6.397 close to 6.5? Yes. Is that number close to that number? Absolutely. So we can get really, really close just by looking at that. And if we wanted to, actually, because your calculator saves your regressions, if I type up, I can get this first one up, and we can see that's what that one looked like. Oh, goodness. Menu, Windows in. Sorry, I want to go 13's fine. Take this from 10 to 32. All right, so that is the one that the calculator derived. If I then press tab again and I put in the one that I had here, which was 13 halves of times the sine of option pi over 6. Sorry, I want one more bracket there. Times x minus x plus 2, and then all of this I'm going to add 21 halves to. You can see between these two, this is the one that we developed by hand, this is the one the calculator did. Are they close? They're super close at the start. They get a little bit less close at the end. But that is the general process of this. So your calculator can do the regression for you, and we can say that we got close enough. Okay? I hope that was helpful.